We've all felt it, that knot in your stomach before a big decision, or the flutter in your chest when you meet someone new. These feelings, often called gut feelings, seem to whisper secrets from deep within us. They can guide our choices and shape our perceptions of the world. But where do these feelings come from? Are they just random sensations? Or is there a deeper connection to our intuition, a kind of inner knowing? For centuries, the idea of gut feelings has been shrouded in mystery. Some believe them to be messages from our subconscious mind, while others see them as remnants of our evolutionary past. Now, with advances in neuroscience, we are beginning to unravel the science behind these enigmatic sensations. Scientists are exploring the intricate connections between our gut, our heart, and our brain, seeking to understand how these organs communicate and influence our thoughts, emotions, and even our most complex decisions. This journey into the depths of our being is revealing a fascinating interplay between our physical sensations and our mental processes. We are discovering that our bodies are not merely vessels for our brains, but active participants in the intricate dance of thought, feeling, and intuition. This new understanding has profound implications for how we view ourselves and our place in the cosmos. It suggests that our intuition, far from being a mystical force, may be rooted in the very biology that connects us to all living things. Deep within our gut lies a complex network of neurons, often referred to as the second brain. This gut brain is in constant communication with the brain in our heads, sending signals that influence our emotions, our mood, and even our cognitive abilities. This intricate communication highway is known as the gut-brain axis. One of the key players in this gut-brain crosstalk is a group of chemical messengers called neurotransmitters. These tiny molecules relay signals between neurons, shaping our thoughts, feelings, and behaviors. Interestingly, many of the same neurotransmitters found in the brain are also produced in the gut. Serotonin, a neurotransmitter known for its role in mood regulation, is found in abundance in our intestines. In fact, the vast majority of serotonin in our body is produced not in the brain, but in the gut. Similarly, dopamine, a neurotransmitter associated with pleasure and reward, is also produced in significant quantities in our digestive system. These gut-derived neurotransmitters don't just stay in the gut, they travel up to the brain via the vagus nerve, a long, meandering nerve that acts like a superhighway of information between the gut and the brain. Through this vagal pathway, signals from our gut can influence a wide range of brain functions, from our emotional responses to our stress levels and even our ability to learn and remember. This constant communication between our gut and our brain underscores the interconnectedness of our physical and mental states. The food we eat, the bacteria that reside in our gut, and the overall health of our digestive system can all have a profound impact on our mood, our behavior, and even our cognitive function. For centuries, the heart has been seen as the seat of our emotions. We speak of heartbreak, heartache, and having a change of heart. Now, science is revealing that there may be more to these expressions than mere metaphor. The heart, it turns out, is not just a pump, but a sophisticated sensory organ with its own intrinsic nervous system. This heart-brain can communicate with the brain in our heads, influencing our emotional processing and even our cognitive abilities. One of the key ways the heart communicates with the brain is through variations in our heart rate, known as heart rate variability, HRV. HRV is a measure of the beat-to-beat changes in the time intervals between our heartbeats. A high HRV, meaning greater variability in the time between heartbeats, is generally considered a sign of a healthy and adaptable heart. It suggests that our heart is responsive to changes in our environment and our internal state. Interestingly, studies have shown that people with higher HRV tend to have better emotional regulation, greater resilience to stress, and enhanced cognitive flexibility. They are better able to adapt to changing situations, make decisions under pressure, and maintain focus and attention. While a high HRV is generally associated with positive emotional and cognitive outcomes, low HRV has been linked to increased anxiety, depression, and even an increased risk of cardiovascular disease. These findings suggest that the heart plays a far more significant role in our mental and emotional well-being than previously thought. The idea that our gut feelings and heart signals directly cause intuition is tempting. However, some scientists believe this view may be too simplistic. They argue that these physiological responses are more likely secondary effects of the nervous system's response to complex stimuli, rather than the primary drivers of intuition. Instead, they propose that intuition might be better understood as an algorithmic process, a complex calculation performed by the brain based on a vast database of past experiences, learned patterns, and subtle cues from our environment. Imagine the brain as a sophisticated computer, constantly processing information from our senses, our memories, and our internal state. Every experience we have, every interaction we encounter is like data being fed into this incredible machine. Over time, the brain begins to recognize patterns in this data, forming connections and associations that allow us to make predictions about the future. Intuition, in this view, is not some mystical sixth sense, but rather the lightning-fast output of this complex algorithm. It's the brain's way of tapping into this vast database of knowledge and experience to make rapid judgments and decisions, often without our conscious awareness. This algorithmic perspective on intuition aligns with the emerging field of computational neuroscience, which seeks to understand the brain as a complex information processing system.